The vessel of the device is made out of mixed materials. The front cover is made out of acrylic sheet. The sides and the back are 3D printed. On its front, we can only see the LCD and the mirror-like acrylic cover. On the bottom of the device, we can see the 3 BNC connector for pH, salinity, and dissolved oxygen sensor. These two fixed sensors are the DS18B20 temperature sensor and NH3 or ammonia concentration gas module sensor. On the right side of the device is the power jack to power up the Wi-Fi module and the LCD. On the other side, we have the USB connector and power jack for the Arduino to power up the sensors. Now let's talk about the specs of the sensor used in this prototype. For the pH sensor, we use the analog pH sensor kit. It is designed for Arduino controllers and has a convenient, practical, and a bunch of features. For most hobbyists, its great accuracy range and its low cost makes this a great tool for biorobotics and other projects. But why we need to keep our pH level stable? Keeping your pond or aquarium pH stable and in optimal ranges reduces stress in your fish and aquatic animals, helping them resist disease and tolerate other stressors. Maintaining an ideal pH can also dramatically improve the growth, behavior, and overall appearance of fishes. The sensor has 5V power module. It has a 0 to 14 pH measuring range and the accuracy is in 0.1 pH at 25 degrees Celsius and has a less than a minute response time. For our salinity sensor, we use electrical conductivity sensor and we converted it from ms per cm to ppt to have an accurate reading of the salinity. As a general rule, salt should not be added to a freshwater aquarium or pond. But in the Philippines, majority of the fish keeper use salt to cycle their water quickly. But remember, salt should never be used in aquariums with live plants. That's why we need to make sure that the amount of salt in our pond are at the lowest as possible. The sensor supports 3 to 5V wide voltage input and it is compatible with 5V and 3.3V main control board like Arduino. It also has a BNC connector like pH and DO sensor. It also has a 5% measurement accuracy. For the dissolved oxygen sensor, we use the analog dissolved oxygen sensor kit, which is compatible with Arduino microcontrollers. It is widely applied in many water applications such as aquaculture, environment monitoring, natural science, and so on. Dissolved oxygen is one of the important parameters to reflect the water quality. Low dissolved oxygen in water will lead to difficulty in breathing for aquatic organisms, which may threaten their lives. To properly use the dissolved oxygen sensor, we need to fill a 0.5 ml per liter sodium dioxide solution on its membrane cap. But before that, please be cautious with the operation because the solution is corrosive. You need to wear gloves. If the solution accidentally drops onto the skin, wash your skin with water immediately. The sensor has 3.3 to 5V wide range power input. It has a 0 to 20 mg per liter detection range and has a response time up to 98% full response within 90 seconds. For the ammonia concentration sensor, we use the MQ137 ammonia detection NH3 gas sensor module analog. It has a signal output indicator light. The analog output increases as the concentration increases. The higher the concentration, the higher the voltage. It has a high sensitivity and selectivity to ammonia. Now, why monitoring ammonia is important? Ammonia is the #1 cause why aquatic life fall apart. Ammonia is toxic to fish if allowed to accumulate in fish production system. When ammonia accumulates to toxic levels, fish cannot extract energy from feed efficiently. If the ammonia concentration gets high enough, the fish will become lethargic and eventually fall into coma and die. But how ammonia form? Ammonia is formed from the metabolism of protein and it's the major waste product of fish. The majority of ammonia from fish is excreted through the gills with relatively little being lost to urine and feces. Ammonia is formed as uneaten feed or other organic matter in an aquarium decomposes. That's why we need to clean our pond and aquarium regularly to prevent this kind of problems. The sensor has LM393 NH3 gas sensor probe main chip and it is also working with 5-volt power input. Lastly, the DS18B20 water temperature sensor. This sensor is very flexible. It can be used in many places such as soil temperature, water temperature, and so on. It must be connected to a pull-up resistor to work properly. It is also working with 3 to 5 volt power supply. The sensor range is in -55 to 125 degrees Celsius. It is compatible with any microcontroller like Arduino or Raspberry Pi. Now, this is how to use the device. First, we're gonna need to plug all the sensors to the prototype. The pH sensor, salinity sensor, and dissolved oxygen sensor. After we plug all the sensor, let's plug the power jack on the left side. As well as the other side. Give it a second to boot up and it will take one loop to load all the sensor. Now, we can see the device is reading up all the sensor data. Let's connect it on the mobile app. Open our Wi-Fi first, then straight to the application. Once the application and prototype are connected, we can see the live graph of sensor readings on the application. We can also back at the previous sensor reading up until the past 3 months. One of its features is, if you wanted to monitor a specific parameter only, just click on the sensor button you prefer, and both of the application and prototype's LCD will display only the parameter you clicked. Let's do some quick spam tests on the application. We can notice a slight delay on the application, but I believe that is just because of the internet connection. Now, let's proceed to testing. But before we actually test it on the water, let's first test it on its liquid solution to prove that our sensors are working properly. Let's start with pH sensor. We have here 3 different liquid solutions. This solution has an individual value. We have 8.8 pH, 6.6 pH, and 4.2 pH. Let's try if our pH sensor is working properly. First, let's dip it on the 4.2 pH. we can see the sensor changes its value to 4.2-ish. Alright, let's test it on the 6.6 pH. As we can see, it changes again on the 6.6-ish pH value. Now let's try it on the 8.8 pH. There you have again, the sensor changes into 8.8-ish pH sensor value. Yay! Let's move on the salinity sensor. For the salinity sensor, we have here two different solutions. One has a salt in it, and the other one is just a fresh water or clean water. We want to see that the fresh water doesn't have any salinity value more than 0.5 ppt. Let's try it first on the fresh water. As we can see on the sensor value, it is just 0.3-ish. Now let's try it on the salted water. It has a value of 11.2-ish. It is a 250 ml of water and 10 grams of salt. Now we can prove that our salinity sensor is working properly. Let's try the dissolved oxygen sensor. Now, since the dissolved oxygen sensor doesn't have a constant value, we are just going to test it on a water from pond with plants in it and just a tap water. We all know that the plants are producing oxygen, so let's see if there is any difference between these two water. Let's try it first on the tap water. We can see on the sensor value that it is decreasing. Now let's try it on the water from pond with plants. Yes, as we can see, it is increasing the value of the sensor. Let's proceed on the temperature sensor. This is pretty self-explanatory. We have here an ice cold water. So let's try if our sensor will read the temperature of the ice cold water. As we can see, it is decreasing like cryptocurrency. And yeah, lastly, the NH3 or the ammonia concentration sensor. We have here two different solutions. One has a huge volume of ammonia in it, and other has a 0% of ammonia. Let's try it. As we can see here, it doesn't even go like a 1 value or 1 ppm value, but here, yeah, we can really see that it has a huge volume of ammonia in it. And yes, we can conclude that our NH3 or the ammonia concentration sensor is working. Now let's proceed to testing of the water. These are the procedures on cleaning the sensors that have been submerged in the water. For the pH, salinity, and temperature sensor, use dishwashing detergent and warm water. Use only soaps that do not contain abrasive or lanolin. Use soap bristle brush or sponge to gently scrub the bulb and reference area of the sensors. Then soak the sensor in warm water for 5 minutes. After 5 minutes, gently wipe the sensor with clean tissue. For the dissolved oxygen sensor, wipe the probe membrane tip with soap, wet cloth, or tissue to remove deposit from sodium hydroxide solution. Then soak it in tap water for approximately 10 minutes. Then wipe it with clean tissue. For the NH3 gas module sensor, just gently brush the whole sensor. Hey, this is JM Nocon and I'm the main developer of the device. For the summary of the study, it is conducted from Feb 2022 to June 2022 to develop this IoT-based fish pond water condition monitoring system. So basically, the purpose of the device is to measure water parameters such as pH level, dissolved oxygen level, temperature, salinity, and ammonia concentration using smartphones. Ngayon, si Arduino Uno and Node MCU are the main components of the device. It is also programmed using Arduino IDE. It is an open source programming software. The program of the system gives the command to function and operate the whole prototype. Lahat ng sensors ay nakakonect kay Arduino. Then si Arduino ay nakakonect kay Node MCU. Then si Node MCU ay nakakonect sa cloud, which gave us an access to the prototype using smartphones. Based on the result of the testing of the device, kita naman natin, the users can simply plug the device in an outlet and it will do the job for you. It will measure your water parameters and it will give you an assistance in monitoring your water. In addition, users can also monitor their water parameters even if they are having an out-of-town vacation, as long as you have your smartphones and you have an internet connection. Also, users can download data logs with timestamp in Excel format using web browsers. In conclusion, we are able to develop the system. The final design of the project gave us a clear view of what actually the physical prototype is. Lahat ng components na ginamit sa study na to ay suitable para sa function ng IoT-based integration. The prototype can accurately read all your water parameters. Based on the testing result, it can read all the data as expected. We compared the buffer solution to the water test to prove that our device is working properly. When it comes to the speed of the device, it is constant because it is programmed to read every parameter like every 0.8 seconds. And for the speed of the application, it always depends on the speed of the internet connection. Yung Node MCU ang nagsilbing bridge to send the data from Arduino to mobile application. Imagine, data needs to travel different location before it reaches its destination, and we did it for like less than a second. The system is able to store all the data readings that has been registered to the cloud. The information includes all water parameters with timestamp and the time that you turn on and turn off the device. Then, wala naman naging problema pagdating sa storing ng data sa cloud because it is highly and strictly programmed. For the security, we can say that it is really secured because we use Google account to access the mobile application. And for the security of Node MCU, alam naman natin na si Node MCU ay really vulnerable dahil open source Wi-Fi module siya. So ang ginawa namin, gumamit kami ng unique tokens to make sure na si Node MCU ay secure. And it can only be accessed by the owner of the Google account. I mean, it is all connected. Then all of the data that was received by the cloud can be seen on the mobile application and web browser. Therefore, the result of the study shows that the output project successfully met all of its objectives. It has proven its accuracy and efficiency, and also I'm hoping that it will give an innovation for the fish farming in the Philippines in the future. So, thank you so much sa lahat ng sumuporta sa study na to. Peace out. Oh wait, let's play the overall UI UX experience. Peace.